Welcome back everyone to part 3 of our lecture series on data frames, where we're going to finally talk about retrieving information from a data frame, grabbing a single column, grabbing multiple columns, and then also creating new columns or adjusting existing columns. So we'll focus first on columns, and then in the next lecture we'll talk about rows. Let's head back to Jupyter Notebook. Okay, here we are back at the Jupyter Notebook. In this lecture video, we're focusing on information based off the columns. In the next lecture, we'll talk about information based off the index. But for right now, I can take a look at the head of the data frame and see that I have these columns. Let's imagine I was only interested in doing operations on the total bill. What I can do is say df, and then in square braces or brackets, you type in the string code for this column. In that case, it's going to be total bill. And what's nice about Jupyter is if you hit tab here, it should auto-complete this for you. Which is nice because if you start accidentally making a typo, like let's say I forgot that A, and I start hitting tab, it doesn't autocomplete because there's nothing that will begin with TOTL. So you can just start typing something, hit tab, and eventually it would complete it for you as long as you're spelling it correctly. One thing to keep in mind here is that the way Jupyter works, if you just hit tab right off the bat, it starts reporting back things that are not columns in this data frame. So just keep that in mind. You should start beginning to type it out, and then eventually you see the name total bill. So when we run this, I get to see this total bill column. So it's just the total bill column. And what's really interesting is if I check the type of this, it will tell me that, as we previously discussed, it's just the Pandas series. So kind of to tell you again that each of these columns is simply a Pandas series sharing the same index. Okay, so that's the way we can grab a single column. What if I want to grab multiple columns? In that case, what I do is I pass in a list of column names. So we'll say df, and then what I'm going to do is pass in a list of column names. So I'll show this in 2 steps, and I'll show it in 1. So I can say my calls as a list is, let's say I want total bill, comma, and then if we scroll back up here, I want the tip column. So we'll say tip, and then I'm going to pass in my calls. Instead of just a single string, I pass them into the data frame, kind of similar to the way we index off a dictionary. We run that, and now I get this kind of little subset data frame. So you'll notice that this is no longer just a series, it's a data frame because there's 2 series here. And you'll also notice I split this up into 2 steps, so I have a list, and then I passed in that list to the data frame. Typically, however, you see this just done in 1 step. So instead of writing this out as a separate list variable, I'll simply cut this out and paste it inside here. And then you'll notice that I end up getting this set of double brackets, and that's because I'm passing in a list of column names. And this gets me back the same result, these 2 columns. So again, that's why we see the double brackets if we're asking for multiple columns. It's because I'm passing in a list of column names. And now moving on, let's imagine we wanted to create a new column. So right now, I have price per person as a column, time, size, etc. Let's imagine I wanted to have a column that told me the tip percentage. Essentially, what is the percentage of the tip in accordance to the total bill. So how do we actually create a new column? Luckily, it's super easy. You can perform operations on these columns very similar to the way we perform operations across NumPy arrays. So I grab one column, such as df tip, and then I can use any sort of math I want. I can say df tip plus, for instance, df total bill. Run that, and then I can see here that it's just simply taking the tip column and adding it to the total bill column for every single row. And so this is the kind of thing we can do for all of these columns here. So then I can also say divided by, run that, and it would begin dividing this. And if I wanted this as a percentage, then I could say 100 times tip divided by total bill. This assumes that the tip is included in the total bill. We run that, and now I get that the tip was, for the first one, around 6% of the total bill. Second one was around 16% of the total bill, and so on. So I can perform operations really easily from different columns together. All I need to do is reference them and then just do the math operations as if they were single values, and the Pandas series will automatically line things up based off the index, which is super nice. Now, what I've done here is I've calculated this tip percentage, again, assuming that the tip is kind of part of the total bill already. And so what we're going to do here then is let's set this equal to a new column. So how do I create a new column? All I do is once I'm satisfied with what I'm actually trying to create here, then I reference the column as if it already exists. So I say df, and let's call this column tip% or tip percentage. And then we set it equal to the series that was returned by this calculation. And now when you run that and you check out your data frame again, what it's going to do is it's going to kind of put any new columns you start to create towards the end here. So now I can see my tip percentage column. And essentially, this is the way you create new columns with Pandas. And this is the same way we created this price per person column. All we did was we said, hey, df price per person is equal to df total bill divided by the size of the party. You run that, and then that's how you could create this price per person. You'll notice that since price per person already existed, if I scroll to the right here, it's not created as a new column. Instead, if you reference a column that already exists within your data frame, it will overwrite the existing column. So it's just something to keep in mind. You should always be careful that if you intend on creating a new column, such as tip percentage, be careful to note that you don't already have a column called tip percentage in your data frame. Because if that's the case, Pandas won't complain. It will simply just overwrite what already exists there. And lastly, you may have noticed that our tip percentage has a lot of floating point values here. Maybe that's not something we want to do. So because Pandas is based on NumPy, we get the really nice capabilities of using NumPy's universal functions along with Pandas, almost as if they were just arrays, which in a sense they really just are. A series is just a wrapper around this NumPy array. So what I'm going to say here is let's go ahead and round this off. So right now my price per person as well, you'll notice it has tons of floating point values here. I probably don't need this many significant digits past the decimal point. So what I'll do here is I'm going to use the same calculation. Price per person is equal to df total bill, df size, but what I can do here is use my universal functions that are available with NumPy. So there's a whole bunch of them, such as np.round is one. And if you look here, you simply pass in the value and then how many decimals you want after the decimal point, essentially how many values you want after the decimal point. And so you pass in this series as if it was just a single value here, and we say np round. And what it's going to do is round every value in this series. So this is our main argument here. And then we say comma. And then we're going to say how many values past the decimal place. Let's go ahead and say 2. And so you'll notice right now we have these values for tip percentage. And also if we saw our current df head. So you notice price per person when I recalculated it or reassigned it, it's a little different now because it keeps the full significant digits, unlike before when I first read in the file. So what I can do is simply pass in np round, run that, and now it should match essentially with what we saw in the first part of our data frame when we first loaded it in. So price per person, it already existed in our data frame, but I just wanted to show you that it would overwrite it if you do something like a new calculation. And oftentimes these calculations will keep many significant figures past the decimal point. So you can always use np.round to shorten that to anything that seems reasonable. So for price per person, it's probably reasonable just to keep it within a penny. Okay, so we talked about grabbing columns, grabbing multiple columns, and then adding new columns. Let's talk about removing columns. So the way this works is you say df.drop. So we say df.drop, and this is actually the general command for dropping either a row or a column. You'll notice here that it takes in the labels, which is either a single column string or a list of columns you want to drop, and then it takes in an axes. So what does the axes represent? It just represents whether or not you're talking about removing a row or removing a column. For df.drop, if you say axis is equal to 0, then it's going to drop it as if it was a row, and if you say axis is equal to 1, it's going to drop it as if it was a column. So a mistake beginners often make is they'll just say df.drop, and let's imagine we want to now remove this tip percentage column that we created right here, tip percentage. Often beginners just say, oh, I'm just going to say tip percentage, go ahead and drop it. And I'm actually going to get a key error if I run this. So it says, hey, key error, this tip percentage isn't found in the axis. And that's because the default axis is axis is equal to 0. So it's looking for a labeled index called tip percentage. Instead, I need to tell it, hey, axis is equal to 1, look at the columns. So I run that, and now you'll notice I only have 11 columns instead of the 12 columns I had when I included tip percentage. Now, a really important thing to note here is that pandas in general, when you call operations like drop or just different method calls off a data frame, typically it does not do them in place. That is to say, it does not permanently affect your data frame. And that's important because you don't want to have done a bunch of work and then accidentally drop the column and then have to rerun a bunch of cells again. So right now you'll notice on in cell right here, number 67, I said drop the tip percentage, and it reports back my data frame with 11 columns with tip percentage.drop. But this change did not occur in place, which means if I call data frame, it actually still has 12 columns. And if we scroll back up here, it still has that tip percentage column. So I need to figure out if I want this change to be permanent, what do I need to do? And there's two options here. One option, we can see if I do shift tab here in .drop, you'll notice that in place is actually the command that would make this permanent. So I'd have to say in place is equal to true. So if you scroll down here, it says in place, if true, do operations in place, and then return none. However, I recommend that you say df is equal to what this actually returns, which is the data frame with that column dropped. So if I copy this, come back up here, paste it in, this is the way that we personally recommend that you perform operations on your data frame if you want them to be permanent. In various GitHub issue updates that we've seen, they intend on eventually deprecating the in-place parameter and instead having this be kind of the default method of Pandas users to eventually make things permanent on their data frame. So in general, we recommend that you use this approach, and that's the approach we're going to use throughout the course because it's a little more future-proof according to some of the posts we've seen online in the documentation and GitHub updates. So just keep that in mind. You can use in place, and you may see in place used throughout other resources online, but we recommend just doing it like this. And now if I see df, the change is permanent. There's only 11 columns. We scroll over here to the right, and I no longer see tip percentage. And to finish off this lecture, a lot of times I get asked, hey, why is axis equal to 0 rows and axis equal to 1 columns? And that all comes from the shape from NumPy arrays. So I can actually say here df.shape, and it reports back 244 rows by 11 columns. And so the reason axis equals to 0 has to do with the rows is because at index 0 of shape, those are your rows. And then axis is equal to 1, the reason that's your columns, is because index 1 here has 11 columns. So it's essentially saying df shape 0 versus df shape 1. And so that's why we have axis equal to 0 for rows versus axis equal to 1 for columns. Okay, so covered a bunch of stuff about retrieving information and working with columns. What we're going to do in the next lecture series is talk about the index. How do we grab information based off the index, and how do we actually add in more rows? We'll see you at the next lecture.